Welcome to this maths made easy video on solving quadratic equations. To start with, let's take a look at solving quadratics through factorising. Now, the quickest and easiest way to solve quadratic equations is by factorising. And you need to be able to spot what we call disguised quadratics. These involve a function of x, f of x, instead of x itself. And you need to use the substitution y equals f of x and solve for y, and then use these to find the values of x. So let's say we've got this example here, where we're asked to solve x squared plus 2x is equal to 15 through factorising. Now the first thing we need to do here is rearrange the equation into the form ax squared plus bx plus c equals 0. So to do that, we need to minus 15 off the left hand side and right hand side of this equation. So that would give us x squared plus 2x minus 15 equals 0. Now here we solve this equation by factorising. So here by factorising we obtain x minus 3 and x plus 5. Okay, and this is equal to 0. So in that case we have two solutions here. We have x minus 3 equals 0, so therefore x equals 3 is one of our solutions. And we also have x plus 5, so x plus 5 equals 0. So that means x is equal to minus 5. Okay, so that gives us the solution there to that example of x squared plus 2x equals 15 through factorising. So that gives us everything we need there for solving quadratics through factorising. Let's move on now to take a look at the completing the square method. So the following method can be used to complete the square of a quadratic expression. For step 1 here, we need the general form of a quadratic expression. So that's ax squared plus bx plus c. If we don't have that to start with, then we need to rearrange the quadratic to be in this form. Now the next step here is to take out a out of the x squared and an a out of the bx term here. So here what that would look like is a bracket x squared plus b over a x. Okay, don't forget our plus c here. Now here we need to halve the coefficient of our x term, and we rewrite the brackets as one squared bracket. So in that case this would look like a bracket x plus b over 2a, and we square this bracket here. Okay. Now next we need to add d to the bracket to complete the square. So this becomes a lots of x plus b over 2a all squared plus d. And to find d, we set this expression equal to the original expression. So this is equal now to ax squared plus bx plus c there. And if we solve this, we obtain that d is equal now to c minus b squared over 4a. So putting all of this together now, what we obtain here is a lots of x plus b over 2a all squared plus, well, we know d is equal to c minus b squared over 4a, so that becomes plus c minus b squared over 4a there. Okay, and that's equal to our quadratic here. So that's equal to ax squared plus bx plus c there. Okay, so that gives us everything we need there for completing the square method. Let's take a look now at completing the square formula. Now you do not need the full steps of what we've just previously seen of working to complete the square of a quadratic. You can just express it in the following form. So if we've got ax squared plus bx plus c, well, we could write that as a lots of x plus e all squared plus d, where e is equal to b over 2a and d is equal to c minus b squared over 4a, okay, which we could write as c minus a e squared there. Okay, so that simply gives us everything we need there for completing the square formula. Let's take a look now at solving quadratics through completing the square. Completing the square isn't the easiest method to solve quadratics, but it is useful when finding exact solutions, i.e. solutions involving surds, etc. So if we take a look at this example here, we want to find the exact solutions to 2x squared minus 12x plus 14 equals 0 by completing the square. So here we can note that a is equal to 2, b is equal to minus 12, and c is equal to 14. So therefore d is equal to b over 2a, so b over 2a, which means that's minus 12 divided by 2 times 2, which gives us minus 3. E is equal to c minus ad squared. So that's 14 minus 2 lots of minus 3 squared. So that gives us 14 minus 18, which gives us minus 4 there. So in that case, we can write 2x squared minus 12x plus 14 equals 0. Well, we can rewrite that then. So if we just get rid of that equals 0 here, we can say now, by completing the square, this is equal to 2 lots of x minus 3 all squared minus 4 there. Okay, using what we obtained for e here. So all we need to do now is put this expression here on the right hand side equal to 0 and solve for x. So therefore 2 lots of x minus 3 all squared minus 4 equals 0. Well, the first thing I can do here is add 4 to both sides of this equation. So we obtain 2 lots of x minus 3 all squared equals 4. We can now divide by 2. So therefore, x minus 3 all squared is equal to 2. And now if we take the square root of the left hand side and the right hand side here, well, that would give us x minus 3 is equal to plus or minus the square root of 2. And therefore this gives us two solutions. What we obtain then is that x is equal to 3 plus root 2 and x equals 3 minus the square root of 2 there. Okay, using this line here. So that gives us the solution there to our example, and that gives us everything we need for solving quadratics through completing the square. And if we just make a concluding note here for solving quadratic equations, well, we can note that to solve some equations, it may be easier to use the quadratic formula instead of factorising or completing the square. For example, when the values of a, b and c are large. However, the questions usually won't tell you which method to use, so this is something you need to gain an intuition for. So that gives us our quick note there for solving quadratic equations, and that concludes this Maths Minis video on solving quadratic equations.